There is a country the size of New Jersey, no rivers worth mentioning, no lakes that matter, rainfall that barely registers on a global map. And yet, this nation doesn't just survive without water. It exports the knowledge of how to create it. Right now, beneath the Mediterranean Sea, massive intake pipes are pulling millions of liters of salt water every single hour. That water travels through systems so large you could walk through them standing upright. It gets pressurized, filtered, chemically stripped, and transformed into something clean enough to drink. And it happens continuously, day and night. Every single day of the year, Israel turned one of the driest places on earth into a country that actually has more fresh water than it needs. That's not a political statement. That's an engineering fact. But what most people don't know is how close this country came to running out entirely. How one drought nearly collapsed the whole system, and what it actually took to build something that no other nation had ever attempted at this scale. The pipelines are real, the plants are real, and the stakes were far higher than most people ever realized. In the early 1990s, Israel was quietly entering a crisis, not a war, not an economic collapse, something far more fundamental. The water was disappearing. The Sea of Galilee, the country's largest freshwater reservoir, had been dropping for years. Engineers measured it carefully, and what they found was deeply unsettling. At the rate Israel was consuming water, the lake would reach what experts call the black line within a decade. Below that line, the water becomes too saline to use, too damaged to recover, effectively gone. Israel had a population that was growing fast, agriculture that needed massive irrigation, and an aquifer system that had been pumped far beyond its natural recharge rate for decades. The engineers knew, the government knew, but the public had no idea how close things actually were. In government offices in Tel Aviv, a small group of water officials and hydrologists began running the numbers again and again, hoping the calculations were wrong. They weren't. One senior hydrologist later said that if nothing changed within 10 years, Israel would face water rationing on a scale the country had never experienced. Not a shortage, a collapse. So a decision was made, quietly, without public announcement, to pursue something that most nations had considered too expensive, too complicated, and too uncertain to attempt at scale. Desalination, turning the Mediterranean Sea itself into a water source. But the moment engineers began drawing up plans, they discovered something they hadn't expected. The ocean wasn't going to cooperate easily. The Mediterranean looks calm from the shore, but beneath the surface, it's one of the most biologically active stretches of water on the planet. And that was the first problem. When engineers began designing the intake systems, the massive underwater pipes that would pull seawater into the desalination plants, they realized the ocean was full of microscopic life, algae, bacteria, tiny marine organisms, and all of it would enter the pipes. In early small-scale tests, biofouling, the buildup of organic material inside pipelines, clogged filtration membranes within weeks, not months, weeks. At full industrial scale, that meant the entire system could shut down faster than it could be repaired. The engineers went back to the drawing board, but the problem ran deeper than biology. The Mediterranean Sea along Israel's coast experiences what scientists call algal bloom seasons, periods where microscopic plant life explodes across the surface of the water. During these blooms, the seawater becomes so dense with organic matter that standard filtration systems simply cannot cope. One early pilot plant near Ashkelon had to be taken offline for 11 days during an unexpected bloom event. 11 days of zero production, and that plant was small. The facilities they were planning would be 20 times larger. The lead engineers held an emergency review. The government was pressing for construction timeline. The aquifer levels were still dropping, and now the ocean itself was proving harder to tame than anyone had calculated. But buried inside the technical reports from that review was a detail that nobody had wanted to say out loud. The biggest threat wasn't the algae. It wasn't the biofouling. It was the salt itself. Salt is not just a mineral. At industrial scale, it becomes a weapon. When seawater is forced through desalination membranes under enormous pressure, the salt doesn't disappear. It concentrates. It becomes a dense, heavy liquid called brine, nearly twice as salty as the ocean itself. And it has to go somewhere. In the early planning stages, Israeli engineers assumed the answer was simple: pump it back into the sea. But marine biologists attached to the project raised an immediate concern. If highly concentrated brine is discharged continuously in one location, it sinks to the seafloor. It doesn't disperse quickly. It sits there, and it kills everything beneath it. Seabed ecosystem, slow-moving marine life. entire microhabitats that had existed for thousands of years. One environmental assessment estimated that without a proper dispersal system, a single large plant could create a dead zone on the seafloor stretching hundreds of meters in every direction. The engineers designed diffuser systems, long underwater pipes with hundreds of small outlets to scatter the brine across a wider area. It reduced the damage, but it didn't eliminate it. And there was something else in those reports, something that didn't make headlines at the time. The desalination process, even when working perfectly, strips the water of almost everything, not just salt, minerals, magnesium, calcium. The water that comes out of these plants is chemically pure, but biologically incomplete. When it entered the national water network and reached agricultural fields, certain crops began showing unexpected deficiency symptoms. The water was clean, but the land didn't recognize it, and that was only the beginning of what pure water was quietly doing to the country. The crops were the first warning sign. In agricultural regions across Israel's coastal plain, farmers began reporting something strange. Leaves yellowing at the edges, growth rates slowing, yields dropping, not dramatically, but consistently, season after season. Agronomists were called in, soil samples were taken, and the results pointed to something that nobody in the desalination program had fully anticipated. The ultra-pure water coming from the plants was so stripped of natural minerals that it was actually leaching nutrients directly out of the soil. Water that is too pure behaves differently than natural water. It pulls, it absorbs, it takes minerals from whatever it touches, including the ground it flows through. Fields that had been productive for decades were slowly becoming depleted, not ruined, but weakened. The government response was measured, controlled addition of magnesium and calcium back into the water supply before distribution, a process called remineralization. It worked, mostly, but here is where the story takes an unexpected turn. While engineers were solving the mineral problem, a separate issue was developing inside the pipeline network itself. The remineralized water, now slightly adjusted in chemical composition, was reacting with the older sections of Israel's national water infrastructure, pipes that had been in the ground for 30 years. The change in water chemistry was accelerating corrosion in ways the original pipes were never designed to handle. In 3 separate municipalities, pipeline inspectors discovered wall thinning in underground mains, detected only because of routine monitoring. If those pipes had failed, contamination would have entered the drinking supply of tens of thousands of people. Nobody panicked publicly, but inside the Water Authority, quiet emergency assessments were already underway. And what those assessments uncovered went far beyond corroded pipes. The assessments revealed something that had been building silently for years. Israel's desalination program had been so focused on producing water that the infrastructure delivering it had never been fully upgraded to handle it. Old pipes, old junction, old pressure tolerances. A network built for one kind of water, now carrying something chemically different. Emergency infrastructure reviews were launched across 7 major municipalities. Engineers worked through nights mapping vulnerable sections of the grid. In some areas, pipe replacement crews were deployed before the public even knew there was a problem. It was managed quietly, efficiently, completely. And that is perhaps the most remarkable part of this story. Because despite every obstacle, the algae blooms, the brine disposal crisis, the mineral depletion in farmland, the corroding pipelines, Israel didn't slow down, it accelerated. Today, Israel operates 5 major desalination plants along its Mediterranean coastline. The largest, the Sarik plant south of Tel Aviv, is one of the biggest seawater desalination facilities on the planet. It produces over 600,000 cubic meters of fresh water every single day. Israel now gets more than 85% of its domestic water supply from desalinated seawater. The Sea of Galilee, the same reservoir that was approaching its black line, has recovered. Water levels are rising. The aquifers are being allowed to recharge for the first time in generations. A country that faced silent collapse built its way out through engineering, adaptation, and relentless problem solving. Not perfectly, but completely. The desert didn't win, and the ocean, for all its resistance, became the solution. If this kind of story is what you're looking for, real, large-scale, and quietly extraordinary, there's more where this came from. Subscribing takes 1 second. The next story might be the one you didn't know you needed to hear.